This is challenge activity 7.1.1. This is about two-tailed hypothesis testing for a population proportion, and this involves one sample. The question is, an online retailer would like to know whether the proportion of customers who visit the site and make a purchase is different than 50%. A simple random sample of customers is taken. The results of the sample are shown here. And the first question is, what is the population parameter? So remember that the population parameter is the unknown value that we're trying to estimate or have an hypothesis about. So any of these options here that involves the sample is going to be incorrect. Any statistic that comes out of the sample is not a population parameter. So you'll notice that the first three options here are all about the sample. The last option is the proportion of all customers who made a purchase on the site, and this is the correct answer here. The population parameter, which is unknown, is attempting to estimate the proportion of all customers, not just those that are in the sample, but all customers who made a purchase on the site. So we will pick this option here. The next question is, what condition for using a z distribution is met? So out of these four responses, this is the correct response, and the correct answer here is actually discussed in section 7.1 right at the start. So this is the correct answer here. What is the level of significance? So if we look at this table here, we can see that the confidence level is 99%. So remember that alpha, which is the level of significance, is 1 minus the confidence level, or 100% minus the confidence level in this case. So it would be 1% or 0.01. What is the null hypothesis? Well, the null hypothesis, because the retailer is attempting to test if the proportion is different than 50%. So the null hypothesis is that the proportion equals 50% or 0.50. What is the alternative hypothesis? Well, this is because we're attempting to test that the proportion is different than 50%. So different means it can be less than or greater than. So that means there are two tails in the distribution. So it's a two-tailed hypothesis test. And so therefore P is not equal to 50%. So this is the only option that involves a two-tailed test. Should the null hypothesis be rejected? Well, the p-value here, you can clearly see, is less than 0.01, which is the level of significance. So we will reject the null hypothesis. And the conclusion is that there is sufficient evidence to support the claim that the number of customers who visit the site is not 50%. So clearly, if we reject the null hypothesis here, then we are going in favor of the alternative hypothesis, which means that the proportion is not 50% or 0.50. And so these are the correct answers. This is challenge activity 7.1.2, and this is about one-tailed hypothesis testing for a population proportion involving one sample. So the question is that a test is modified so that the proportion of test takers that pass is more than 75%. Simple random sample of test takers is collected, and this is to determine if the proportion of passers is greater than 75%. The results of the sample are shown here, and so we need to answer these questions. So why don't we start here with the sample size? So in this table, we can see that we have a total of 100 observations. 86 of those 100 students passed. The confidence level is 0.99. Critical value is 2.33. So these are hypothesis test results. The z statistic is 2.54, and this is the p-value. So n clearly is 100. The numbers that passed is 86. And so therefore the proportion is 0.86. Now this is the sample proportion. So the estimated value using the sample. The p-value for this test is 0.005, and the z statistic is 2.54. So we've answered all the questions here, and so these are all correct. Go to the next question. Now here, an airline would like information on which seat is preferred by customers. The airline assumes the majority of customers prefer the window seat. So they're looking for evidence to support that claim. So majority of customers meaning more than 50%. The results of a simple random sample of customer seat preferences is shown here. So first we need to identify the population parameter. Now again, we recall that the population parameter is the unknown value that we're trying to estimate using a sample. And so population parameter will not involve anything related to the sample. So all these three options here are about the sample. So those are not correct. Here, the proportion of all customers who prefer the window seat. So this is the correct response here, because this is what we're trying to estimate using the sample. Now, what condition for using a z distribution is met? So this is given in section 7.1 at the start of 7.1. And so the correct response is here. The level of significance. So we notice in this table, the confidence level is 0.9. And we recall that the level of significance, which is alpha, is 1 minus the confidence level. So 100% minus 90%, or 1 minus 0.9. So that would be 0.10, 10%. What is the null hypothesis? So again, we're looking at the proportion. So it's p, and we're going to say it's equal to 0.5. The null hypothesis always involves the equal sign. What is the alternative hypothesis? So because the airline is assuming that the majority of customers prefer the window seat, so p is greater than 0.5 for the alternative hypothesis. Now, should the null hypothesis be rejected or not? So we notice that the p-value is 0.21. It's pretty high and is greater than the level of significance, 10%. So we will not reject the null hypothesis. And the conclusion is that insufficient evidence exists to conclude that majority of customers prefer the window seat. And so these are the correct answers. This is challenge activity 7.1.3, and this is about hypothesis test for a population proportion. And the question is, a software company is interested in improving customer satisfaction rate from the 51% currently claimed. So there's a survey done of 141 customers, and they found that 78 were satisfied. The question is, what is the test statistic z for this question? So I've created a template here in Excel that we will follow. So n here is the total sample size. S is the success rate, or whatever the company is interested in. In this case, it would be how many customers were satisfied. P here is the sample proportion, so we will calculate that. And so naturally that will be equal to the S minus S over N, or the successes over N. So right now it's just giving an error because there's nothing in these cells, but we will fill this out. This P0 is the proportion under the null hypothesis. So that is provided in the question here as 51%. So I can just type 0.51. And we will then calculate Z here. So what we need to do is, first we need to find the sample proportion. So 78 out of 141. So 141 here and 78. So the sample proportion is 0.55. Now, the formula for calculating the Z statistic is sample proportion minus proportion under the null hypothesis. That's the numerator. And in the denominator, we have square root of the proportion under the null hypothesis times 1 minus proportion under the null hypothesis over n. So that's the formula. So let's just type it out. First, I will type the numerator, which is p minus p0 here. So this will be in parentheses and then divided by square root of p0 times 1 minus p0, and this I will also include in parentheses, and then over n, which is the sample size here. And so the z test statistic is 1.026. So we just need 2 decimal places. So 1.02, or it will be 1.03, because when you round off, you get 1.03 here. So that's the correct answer here. The next question is, an airline company is interested in improving customer satisfaction rate from 73%, which is the current claim. And so the company sponsored a survey of 244 customers and found that 187 were satisfied. And so we need to test whether sufficient evidence exists that the customer satisfaction rate is higher than the claim by the company, higher than the claim. So clearly this is a one-tail test. And the alternative hypothesis is that the proportion is greater than the claim, which is 73%. So first, we need to find the test statistic z. So we can use the same template here, and let's just update the numbers. So the sample size this time is 244. This is 187. And the proportion under the null hypothesis is 0.73. So our test statistic is 1.28. Now we need to find the p-value, and remember this is a one-tail test, and the tail, because the alternative hypothesis is that p is greater than 73%. So the tail is on the right side of the distribution. So what we can do is we can use Excel norm.dist function. The x here is going to be this z value, and because we have normalized it, so it's the normal distribution, the mean is 0 and the standard deviation is 1. And for cumulative, I'm going to type true for now. So this gives us the probability, and this is the cumulative probability, that p is probability of z 1.28 that is less than 1.28. So it's the probability that z is less than 1.28. But we need the right tail p-value, right? So we can use the trick that probability must sum to 1. So the right tail will be 1 minus that. And so the p-value is 0.10. And now we need to come up with a conclusion. So is there sufficient evidence? And alpha is given as 5% or 0.05. So clearly p-value is greater than alpha. So we will not reject the null hypothesis. So there is not sufficient evidence that the customer satisfaction rate is higher than the claim by the company. So we're going to say no. So that's the correct answer here. Let's go to the next question. So now we have a home improvement company is interested in improving customer satisfaction rate from 75%. And again, there's a survey of 240 customers, and they find that 187 are satisfied. Now we need to test whether there's evidence that the customer satisfaction rate is different than the claim. And so because it's different, it's a two-tailed test. And so the null hypothesis is p equals 0.75, and the alternative is p is not equal to 0.75. And again, we need to find the test statistic and the p-value, so let's start there. So we will use the template again, and let's update these numbers. So sample size was given as 240, 187 here, and proportion under the null hypothesis is 75%. So let's just make sure that's correct. Yep. Okay, so the z test statistic value is 1.04. And now we need to find the p-value. Now for the p-value here, it's slightly different. It's, because we don't have one tail, we have two tails. So what we need to do is first find the one tail value. And one tail value we can find the same way as we did before. It's 0.1483. So this is the right tail, but we also have a left tail this time, and the p-value for that is the same. So we're going to just take this and multiply it by 2. This is the p-value for this test. And because, again, this is because it's a two-tailed test. So it's 0.30, or we need 3 decimal places, so it's 0.297. And the question is if there's sufficient evidence, and again there is no sufficient evidence because the p-value is greater than 0.05. So that's the correct answer. This is challenge activity 7.1.4. This is about hypothesis test for a population proportion, and these series of questions you'll be answering by working in this Excel sheet that you can download by clicking this link. So let's go over the first question. In order for a candy company to claim that a bridge mix is mostly chocolate stars, a proportion of at least 0.8 of the packages must contain 3 ounces or more of chocolate. And so there's a quality control test that it takes place, and so there's a random sample of size 50 to determine if the proportion is less than 0.8. So right away we can tell that this is a one-tail test, and the tail is on the left side of the distribution. And we're going to use sheet 4 of the Excel file. So I've already downloaded the Excel file, and I'm on sheet 4 here. And so we have this data provided to us. This gives the weight of chocolate stars in each of the 50 packages. So there should be 50 data points. So this is again the weight of the chocolate, and we need to know how many of the packages contain 3 ounces or more. So we need to count how many of these 50 have the weight of chocolate more than 3 or more. So we can either just go through this one by one, but there are 50 data points, so that obviously takes a little bit of time. There are multiple ways to do this. We can sort and just count how many are above, greater than or equal to 3 out of the total 50. But here what I will do is I will use the equal if formula. And here, so this is a logical test, and the test I'm going to do is whether this value is greater than or equal to 3. And if it is, the first value, what happens if this is true? Then I will give it a 1, otherwise I will give it a 0. Okay, so this is less than 3, so clearly it gets a 0. So now what I can do is, if I hover over lower right corner and then double click, it will copy this formula all the way down to the 50th value. So now you can see here, for example, weight is greater than 3. So this is a 1. Same here. Okay, so now I can calculate. So let's see what is the total sample size is 50. And the number of successes. So how many ones are there? For this, I can just say equal sum. And I can click here on column B, enter. So this gives me the sum, 36. 36 out of 50. So there are 36 cells out of 50 total where the value is 1. So the P is calculated as 36 over 50, 0.72. Okay. Now the null hypothesis has P equal to 0.8. Okay, so under the null hypothesis is 0.80. All right. The first question is what is p hat? So we already calculated that, 0.72. We need to find z. And so for z, I can just type out the formula here. So it's equal to, the numerator is p minus p0, and the denominator is square root of p0 times 1 minus p0 over n, parenthesis. So it's minus 1.4142. So I'm going to type this to 4 decimal places here. All right, and now we need to find the p-value. Now recall that this is a one-tail test, that the tail is on the left side of the distribution. So I will use, for p, we can use norm.dist formula. This is the value, and because it's normalized, so we have 0 mean, 1 standard deviation, and for cumulative I'm going to type true. And because the tail is on the left side of the distribution, this is all we need to do to get the answer. So the answer is 0.07865. Okay, so let's just double check this, 0.07865. Yep. Now we need to compare it to the alpha, which is 0.05. So clearly this is, the p-value is greater than 0.05. So we will not reject the null hypothesis, or the null hypothesis fails to be rejected. And there is insufficient evidence that the proportion of packages with 3 ounces or more of chocolate is less than 0.8. Okay, and this is the correct answer. The second question is, a bank has a policy that the proportion of loans made to people with more than 50,000 in debt should not be more than 15% or 0.15. So there's a sample of 75 customers' debt amounts, and so we're going to carry out this hypothesis test, and the main test here is we need to determine if the proportion is more than 0.15. So now this time it's again a one-tail test, but the tail is on the right side of the distribution. So the alternative hypothesis is that p is greater than 0.15. We're going to use sheet 1 of the Excel file. So let's go to the Excel file, and again, the rule that we're checking is if debt is more than 50,000. So here I've basically what I've done here is I've added the same formula that I just used, and this time we're testing if this value here is greater than 50,000, and if it is, then it's a 1, otherwise it's a 0. All right, and I will, again, if we hover over lower right here of this cell and double click, this will copy the formula down, and so we can see that there are 13 instances where the value is 1 out of 75. So the p is 0.173, and under the null hypothesis, p0 is 0.15. So I'm going to change this to 0.15. Okay. All right. So first question is, what is p hat? P hat is the sample proportion. So that is 13 divided by 75 is 0.1733. Now we need to find the z value for this. So the z is calculated here. So just to go over this again, it is simply just p minus p0 as the numerator divided by square root of p0 times 1 minus p0 over n, sample size. So it is 0.56592. And the p-value now, this time we're interested in the right tail p-value, right? So we're going to use norm.dist function, which gives us the cumulative probability that p is less, that z is less than 0.5659. So to get the right tail p-value, we'll just do 1 minus that. So it is 0.28573. Now, since the p-value obviously is greater than 0.05, the null hypothesis fails to be rejected, and there is insufficient evidence that proportion of loans to people with more than 50,000 in debt is more than 0.15. So these are the correct answers here. The third question is very similar to the last two. A charity claims that a proportion of 0.75 of donations go to communities where the average family income is less than $20,000. So here, the proportion is going to be defined as the sample size in the denominator, and the numerator will be the number of instances where the average family income is less than 20,000 out of the sample size. So a watchdog group checks a random sample of 60 that received the funds, and they're interested to determine if the proportion is different than 0.75. So different meaning this is a two-tail test. It's not a one-tail test. So the alternative hypothesis is P is not equal to 0.75. All right, and we need to use sheet 9 of the Excel file that gives average family incomes for 60 communities. So sheet 9 is here. So I've already typed in 0.75 here for the proportion under the null hypothesis. So that's given here. And let's figure out how many of 60, how many instances we have where the income is actually less than 20,000 out of the 60. So again, we can use the if formula here. You can see I've typed in if this value is less than 20,000, then it's a 1, otherwise it's a 0. It's a 0 here because it's more than 20,000. And again, I will hover over lower right side of the cell and double click, and this will copy the formula down to all of the cells. And you can see that there are 39 out of the 60 where the income is less than 20,000. So the sample proportion is 0.65. So that answers this question. Now we need to find the z. So again, we have 0.75 here. Z is going to be p minus p0. That's what the numerator is, divided by square root of p0 times 1 minus p0 over n, the sample size. That's what this formula is. And so we get minus 1.78885. Okay, so minus 1.78885. Now for the p-value, recall that this is a two-tail test. So first we find p-value of one tail, which is given here. That's just norm.test of this value. So G6 is this value. And because it's normalized, so the mean is 0 and the standard deviation is 1. And we need the cumulative probability. So we set this cumulative parameter to true. So this is one tail value. To get the two tail value, I can just simply take this and multiply it by 2. Okay. So that's 0.07364. So 0.7364. Now we compare it to the alpha, which is 0.05. So clearly the p-value is greater than alpha. So the null hypothesis fails to be rejected, and there is insufficient evidence that the proportion of donations to communities with an average family income of less than 20,000 is different from 0.75. And so those are the correct answers. This is challenge activity 7.2.1, and this is about confidence intervals for population proportions. We've been given this table of confidence level and the corresponding z value, so we will be using these in these questions. So the first question, we have a poll of 1,000 randomly selected voters in a local election. 867 were against fire department bond measures. The first question is what is the sample proportion, and the second question is what is the margin of error. And the confidence level to use is 90%. So I've created this table here again. So in this table, n is the sample size, so we will enter that here. S is defined as the number of successes in the total sample size, so we will enter that number here. This will automatically then calculate the p-hat, sample proportion. Then we will enter the z critical value here for the given confidence level, and this will then give us the margin of error. So recall that the margin of error is, the formula for that is z times square root of p-hat times 1 minus p-hat over n. So the square root is for all of this expression. And so that is what I've entered here. So we can see it's this times square root of this times 1 minus that over b1, which is the sample size, right? Okay. So let's enter these values here. So we have sample size of 1000. S is 867. So we get P is 0.867. And what is the margin of error for 90%? So for 90%, you can see the Z is given as 1.645. So I will enter that here. And that gives us the margin of error of 0.01766. So we can enter this here and we can round to 3 decimal places. So it's 0.018. Okay, so that is correct. Let's go to the next question. And again, we can just erase this data now since we have new data to enter. So now we have a poll of 1000 randomly selected voters, and there are 540 that are in favor of 5 department bond measures. So we have 1000. Now the success is defined as voters that are in favor of the bond measure. So there are 540 of them. So that's that. And this time we need the confidence interval. So I entered 540 and we get our sample proportion, which is 0.54. Now we need to know the Z value to enter here. So Z for 90% again is 1.645. So let's enter that here. That gives us the margin of error of 0.0259. The confidence interval, the lower limit, is 0.54 minus the margin of error. So 0.54 minus 0.0259. And the higher limit is 0.54 plus the margin of error, 0.0259. So that's that. So we will enter those values here. And we need 3 decimal places, so these are the correct answers. Right, next go to the next question. Now here we have a poll reported 63% support for a statewide election with a margin of error of 4.23 percentage points. How many voters should be sampled for a 90% confidence interval? All right, so now we need to find the sample size. So this formula is provided in this section. So be sure to go over that, but I've also typed it here. The formula is n equals Z over M. Z is the critical value for the confidence level. M is the margin of error. We take the square of that times P times 1 minus P. Okay. So if P is not provided in the question, then we would just use 0.5. But here it is provided. So a poll reported 63% support. All right, so let's calculate this. 90%, so we will use 1.645 over margin of error is 4.23 percentage points. So we need to convert this to percentage, which would be 0.0423. We take the square of that times 0.63 times, let me just expand this here, 1 minus 0.63. That gives us 352.5. So at a minimum, we need 352.5. So obviously we need to round this, and we need to round it up to get to a whole number. So that would be 353. And so that is the correct answer. And then the last question here is a poll for a statewide election has a margin of error of 4.91 percentage points. How many voters should be sampled for 99% interval? So notice this time we don't have we don't have p, and so we will use 0.5 for the proportion. So the sample size here would be, let's get rid of this and type it again. Z for 99% is 2.576 over M. Margin of error is 0.0491. So it's 4.91 percentage points. So we need to convert that to percentage here. That way, we take the square of that times 0.50 times 1 minus 0.5, which is also 0.50. I get 688.12, and we need to again round it up. So 689 is the correct answer. This is challenge activity 7.2.2, and this is about confidence interval for population proportions. The question is, understanding student demographics is important for a college in deciding what programs will most benefit students. So a sample of students is taken to determine the proportion of students that identify as Hispanic or Latino, and here are the results. The question is, what is the population parameter, point estimate, and we need to get the confidence interval here. So I can use the template again to answer this question. So we can see that the sample size is given as 400, and out of the 400, 68 students identify as Hispanic or Latino. So that's 17%, 0.17. And you'll notice that the confidence level here is 95%. That's what we are looking for. So for 95% confidence level, the Z value is 1.96. So I'm going to type that here. So what is the population parameter here? The population parameter is the proportion of all students at the college that identify as Hispanic or Latino. So it would be this here. What is the point estimate? P hat. The sample proportion again is 17%. It's 68 divided by 400. So that's 0.17. And then we need to create the confidence interval. So again, we can calculate the margin of error, which is the Z value times square root of P, 0.17, times 1 minus 0.17, and then all of that expression divided by n, and the square root is for the entire expression. So that's what this formula is here. And so that gives us 0.0368. And then the confidence interval is sample proportion minus the margin of error for the lower value, and for the higher value it's sample proportion plus the margin of error. So let's enter these values here. So 133 is the lower value and 207 is the upper value or the higher value. Now we need to pick what confidence level we're working with, and it's 95%. And so this is the correct answer. This is challenge activity 7.2.3, and this is about confidence intervals for proportion. And for this activity, you will click on this link to download a spreadsheet that I have already downloaded here. And we will use the critical values that are shown here for the various confidence levels, whatever the question specifies. So let's get started with this. So in this question, we have a manager of a bookstore with a coffee shop wants to know the proportion of customers that come into the store because of the coffee shop. A random sample of 75 customers was polled, and we're going to use sheet 1, which I've already opened here, to answer these questions. Now, again, the questions are fairly similar to the previous challenge activities in this section. We are going to have a sample size here, the number of successes as defined by the question. Like in this case, for example, the success is that the customers, they come into the store because of the coffee shop. So that's what we're going to count. And then here, this will calculate the sample proportion, which is S over N. And then we are going to use Z here to find the margin of error. And then using that, we can find the confidence interval. So let's get started here. Now, in this sheet, we have this question. They come because of the coffee shop. So it's either a yes or a no. So this time, I will use the if formula here to say if this equals, in parentheses, yes, then we will, the condition will be that it's a 1, otherwise it's a 0. So this is a 1 here, this cell is 1 because this cell has a yes in it. And then again, if I hover over the lower right corner of the cell and double click, that copies the formula down to the 75th row here. Now, you can see whenever this cell has a no in it, that's a 0. Okay, so now we have 75 total sample. For the number of successes, we will just use equals sum, and we can click on this header here for B. Oops, let's type this again. And remember to type the parentheses here and then click on the header for B. So 32 out of 75. So that answers the first question, which is what is the sample proportion P hat, which is 0.427. The upper bound for the 95% confidence interval. So first we need to enter the Z value here. It's 95%, so the Z value is 1.96. And that gives us the margin of error here. Margin of error is Z times square root of P times 1 minus P over N. Okay, so that's what is shown here in this formula. Okay, and so the upper limit is P plus margin of error. That's 0.5386. And I enter just 3 decimal places here. The lower limit is P minus M. So it's 0.315. The manager can say with 95% confidence that the true population proportion of customers that come into the store because of coffee shop is in this interval. It's in this confidence interval. So first we will type the lower limit, and then we will type the higher limit. Okay, so those are the correct answers. The next question here is a hunger relief organization is trying to determine the lowest likely proportion of the local population that lives within 2 miles of a grocery store. A random sample of size 50 is drawn. Sheet 5 is where we're working with, so I've already set it up here. So let's look at this. So again, yes is going to be our success. So we need to count how many yeses we have here. And again, I've typed if this cell equals yes in quotes, then it's a 1, otherwise it's a 0. So that formula is typed here. So again, I will hover over lower right side of the cell, double click, copies the formula down to all of the cells here. So we have 50 sample size, and the number of successes, we can use the sum formula again, click on the header B, and that counts the count is 11. So 11 out of 50 live within 2 miles. So 22% or 0.22. That's the p hat. To find the confidence interval, we need to know the z value that we're going to use. So again, it's 95% confidence level. So 1.96 is the z value. So this gives us our margin of error. And again, we get our lower and the higher limits for confidence interval. So the upper bound is the higher limit, which is 0.335. The lower is 0.105. And now the organization can say with 95% confidence that the true population proportion of the local population that lives within 2 miles of a grocery store is in this interval. So we'll type the confidence interval here. Lower limit comes first and then the upper limit. The lowest likely proportion is, so the lowest likely can only be the lower bound of the confidence interval. The most likely will be the upper bound of the confidence interval, right? So here in this case, it would be 105. And that's correct. And now the last question is, a biologist wants to know the highest likely proportion of squirrels in the area that are affected with a particular disease. We have a random sample of 100 squirrels, and using sheet 7, which I already have opened here. So let's go over this. So again, yes is considered success. So we need to count how many yeses we have here. The total sample is 100. So I've already typed the formula. The formula is if A2 is, if this cell is yes, then it's a 1, otherwise it's a 0. So we get a 1 here because it's a yes. And we'll copy this down to all of the rows here. All right, so we have 100 is the total sample size. To count the number of successes, we use the sum formula, and we get 41. So the proportion is 0.41. Now we need the 95% confidence interval again, so we will use 1.96 for z. And that gives us the margin of error. And then the confidence interval for the lower limit is p minus the margin of error. And the upper limit is p plus the margin of error. So the upper bound here is 0.506, which is here. The lower bound, again, the upper bound is p plus margin of error. The lower bound is p minus margin of error. That's given here, 0.314. Now, the biologist can say with 95% confidence that the true population proportion of the local squirrel population that is infected with the disease is in this interval. So we type the lower bound first and then the upper bound here. Oops, and I forgot to enter this value. So let's just go ahead and enter this. The highest likely proportion is, it would be the upper limit, the upper bound of the confidence interval. So 0.506. And these are the correct answers.